In the last video, we started to extract a bunch of logic out to the numbers collection. So we're going to create that class right now and start to implement some of these very specific methods that tell our sorter how to somehow swap elements in that array or compare elements inside that array. So let's get to it. All right, inside my src directory, I'm going to make a new file called numberscollection.ts. Then inside this file, we're going to put together some scaffolding for a class. So I'm going to create and export class numbers collection right away. Remember, we had said that this thing needs to have a reference to the array of numbers that we actually want to sort. So I'm going to give this thing a property that I'll call data. Again, we can call it anything we want. Just in this case, I'm going to call it data because, whatever. And it's going to be of type number, array of number. Now we're going to have to eventually initialize this. Chances are we're going to want to pass in the array of numbers we actually want to sort to our numbers collection when we create it. So to do that, we would have to define our constructor, receive some argument that we might call data, and it's going to be an array of numbers. And then we would take that argument and assign it to our data property like so. All right, quick reminder, the exact syntax you see right here, we can condense down by just putting on a modifier in front of data of public like so, removing that assignment, and then removing the initialization up there, the declaration up there like so, 100% equivalent. All right, so now we have a class called numbers collection that is going to have a reference to the data that we want to eventually sort. So now inside this class, we're going to define some different methods that are going to contain the super customized logic to compare two elements and decide if they need to be swapped, and then to actually swap them. So let's first declare a method inside of numbers collection called compare. So I'm going to define compare. This thing is going to return a Boolean to indicate whether or not this pair of elements need to be swapped. So again, if we go back over to our sorter.ts, this method we are defining, it needs to do exactly this right here. This is what we are trying to replace. We want to compare the two elements next to each other and decide if they need to be swapped. So inside of compare, we're going to take in two arguments. The first argument is going to be the index of the left-hand side of this pair. So I'll say left index is going to be a number. And then the second argument is going to be a right index. Let me make sure it's really clear what the purpose of these two arguments are. Like we just said, the goal of this overall method right here is to decide if we need to swap two elements in a pair. And when I say two elements in a pair, remember the entire point of bubble sort is that we compare each little pair of elements all the way through the collection of data. So like compare those two, then compare those two, then compare those two, and so on. And so we need to know at all times what two elements we are trying to compare. So that left index is going to be the index of the element on the left-hand side of the pair. And then the right index, or the second argument, is going to be the index of the right-hand side of that pair. So in this case, it would be 0 and 1. So index 0, index 1. When we then moved on to the next pair, it would be index 1, index 2. Now, you're probably thinking we don't actually need both indices right here, because the right index, or like the right-hand side of the pair, is always just like the next element over. We could potentially just take left index and then add 1 to it. So in other words, we don't need to know that we need to compare 0, or index 0 and index 1. We really only need to know we need to compare index 0. And then we can just add 1 to that, and that would tell us, oh, okay, we need to compare that with the next one over. So we could do that. We could shorten up the argument list right here to be just one element or one argument, but we're just going to receive 2 just so it's really clear to everyone to hear that we are trying to compare 2 elements against each other. Okay, so now inside of here, we're going to do the actual comparison logic and then return the Boolean to say whether or not these elements need to be swapped. So I'm going to return this.data at left index, and if the element on the left-hand side of the pair is greater than the element on the right-hand side of the pair, right index, then yes, we want to swap these two things. So if compare returns true, then yep, we need to swap these things. Otherwise, if we return false, it means they are already in the correct order and no swapping is required. Okay, so we have now extracted out compare. That means that back inside of sorter, we have now taken this comparison right here and extracted the array-specific implementation of it into that helper method. So let's now do a very similar thing. We're going to extract the swapping logic over to a helper method on numbers collection 2. So back inside of numbers collection, I'm going to define a method called swap. I don't expect this to return anything. And as arguments, we're going to receive the left index and the right index that we are trying to swap. So again, this would be the case in which we are saying like let me just update the diagram really quickly. So the entire point of bubble sort, once again, we are trying to say is 0 greater than -1. If it is, then we should swap these two. So the comparison right there was the compare function we just put together. So now if we succeed in that comparison and we do need to swap these, we now need to actually swap them. So we're going to take in the index of the two elements that need to be swapped. So first argument will be the left index, and then we'll get our right index. And once again, those are the two elements that we're trying to swap. So then inside of here, we're going to do the swapping logic specifically for an array of numbers. And so this logic is going to be just about identical to what we have back over here. So we'll say left hand. This is the left hand value. Notice I'm saying left hand here, not left index. So left hand is going to be this dot data at left index. So that's a reference to the element on the left-hand side of the pair. We'll then take the right-hand side and throw it into the left-hand index. So I'll say this dot data at left index is this dot data at right index. And then finally, we'll take our reference to the left-hand value that we are saving here and throw it into the right-hand spot. So I'll say this dot data at right index is left-hand, like so. Okay, a lot of places inside of here that you can make a typo. Chances are if you make any typo, your editor will tell you, but just to make sure it's really clear, if I click on left index, I should see left index highlighted, left index, left index. And if I click on right index, I should see right, right, right. And if I click on left hand, I should see left hand and left hand, like so. So make sure you've got all the same references, same spelling, everything inside of here. Okay, now the very last thing we have to do here, remember back inside of our sorter, to figure out how many elements we are iterating over, we pulled off the length property from our collection. So we need to make sure, if we want to keep this same syntax right here, we need to make sure that our collection, which is going to be our numbers collection, has a length property available on it. So this is going to be the number of elements inside of this data array right here. Again, this is to tell our for loops exactly how many times they are iterating over our collection, or how many steps of iteration there are, I should say. So to do this, a couple of different ways we can do it. We could add on a new method here called length. And this would return a number. And then from it, we could return this .data.length, like so. So this is definitely one way to do it. But notice how in this case, we would have to call length as a method. Another way that we could do this that would be just a little bit more natural, because usually whenever we get the length of an array or a string, it's just a property, not a method we have to call. So another way we could do this is set up a getter, or something called an accessor. Well, let's write out some syntax, and I think you'll get the idea of what we're doing here really, really quickly. So in front of length right here, I'm going to put the keyword get, like so. And you'll notice nothing has changed. The only thing that is now changed is how we would now call this method. If we now created a new instance of numbers collection, so I'm going to do that really quickly down here, and I passed in some array of numbers like so, and assigned it to some variable. Now to get the length property of that array right there, I could do collection.length, like so. So when I say .length, I'm referring to this function right here. But because I put on the keyword get, I do not have to call length as though it were a function. So I do not have to put on a set of parentheses right there. And as a matter of fact, if I do, I will see an error message. So the point of this little get keyword right here is just to make sure that we can reference length in the way that we are usually used to doing so whenever we've got an array or a string. All we have to do is reference the length property, and it's going to reach into our data array and return the length of data array. Okay, so I'm going to remove that test code down there really quickly. I'm going to save this file, And now the very last thing we have to do in this very long section, I apologize for the length, we have to go back over to our sorter, and we're going to wire up the numbers collection to it. So I'm going to go back over to sorter. Remember, we had said that the big thing we had to do here was eventually annotate the type of collection. So at the top, I'm going to import numbers collection from the numbers collection file. And then I'm going to update that annotation, and I'm going to say that this collection instance property is going to be an instance of a numbers collection like so. And now you'll immediately see a ton of errors appear. So we need to essentially go back into this implementation right here, and rather than trying to work with this.collection as though it were a plain array, remember the entire idea here is that we are delegating out all those very complicated operations to this outside class that knows exactly how to deal with a comparison for a array of numbers and how to deal with swapping in an array of numbers as well. So we essentially need to just add in that code right there. So rather than us trying to do this comparison right here directly inside of our sorter, we're now going to say, just call this.collection.compare. And we're going to pass in the two indices that we want to compare. So that's going to be j and j plus 1, like so. And then we'll do the same thing for the swapping logic right here as well. I'll say this.collection.swap at j plus 1. All right, and that is it right there. That's everything. So the entire point here, one more time, I know I've repeated this many times, but the entire point here is we've now extracted out all that very array-specific comparison and all the very array-specific swapping into a separate class. So now the very last thing, let's test this out and make sure that everything still works as we would expect. So I'm going to save both sorter and numbers collection. I'm going to go back over to index.ts. And then over here, I'm going to import sorter from sorter, numbers collection from numbers collection. I'm then going to create a new instance of a numbers collection. I'll call this thing like, how about just numbers collection? No need to be fancy. So this will be a new numbers collection, and I'm going to pass in the array of numbers I want to be sorted. So I'll do like 10, 3, -5, and 0 again. And I'll zoom out just for a second. And now when we create our instance of a sorter, no longer are we attempting to sort or pass in the array of numbers we want to sort directly. Instead, we are passing in an object that has the data we want to sort and those two very specific implementations for those two steps that are going to be very different for every type of data we try to sort. So now to new sorter, I'll pass in numbers collection like so. We'll do the sorting step. And then finally, rather than trying to console log out sorter.collection, let's just console log out the array of numbers directly, which is available on numberscollection.data. So I'm going to console log numbers collection.data like so. And that's it. Whew, that's a long refactor. So I'm going to save this. Let's make sure it worked. Flip on over to my terminal, and I'll see the sorted numbers. Sure enough, no errors whatsoever. Just to make sure everything actually did work here, I'm going to change one or two of these numbers. I'll put 100,000 right there at the very start. I'll save it again, and yep, there we go. All right, so I've now spoken a ton about this. I've repeated some concepts so many times, so I'm not going to do any review here. Let's just stop right here. We're going to come back in the next video. We're going to point out one last deficiency, and then start the last refactor we have to do. So quick pause, and I'll see you in just a minute.